Okay, we're now going to talk about one important rule about energy, which is called the conservation of energy. And we're going to start by looking back at this diagram of a light bulb and the flow diagram that relates to it. So remember, this is an LED light, which are a really efficient type of light bulb. And we can use our flow diagram to see that out of 100 joules of electrical energy that goes in to the light bulb, 75 joules is converted to light energy and only 25 joules is wasted as heat. So an LED light bulb we know is 75% efficient. But you might also have noticed that if 75% was converted to light, 25% was wasted as heat, whatever energy went out, and in this case it equaled 100 joules, it always has to equal the energy that went in. 100. And this is called the conservation of energy. It's something that scientists discovered, that whenever energy is going into a process, the same total amount of energy comes out at the end, even if it can transform into different forms of energy. And what scientists actually have called this is the law of conservation of energy. And in science, whenever something is called a law, that means scientists have done so many experiments, and whenever we've looked at nature or anything happening in the universe, this always is true. So as much as we know now, we're confident that a law is always true in science. And the proper way to say the law of conservation of energy is that energy can't be created or destroyed. It can only be converted into different forms. Can't be created or destroyed. It's only converted into other forms. And we've learnt about those conversions, and we call them energy transformations. So what we'll do now is have a look at an example of the law of conservation of energy in this pretty complicated looking diagram. But what it's showing here is an average household. We can see the house in the background, and this is showing all the energy that goes into an average house and all the energy that goes out, in whatever form it is. So the main thing we can see here is this is all the energy going into a house through the heating. Maybe it's through gas or just electricity. And the units here are kilowatt hours per square meter, but we can just think of them as numbers. The unit doesn't matter too much. We have about 570 units of heat going in. And then from the sun just beating down on the house, we also have 24 units going in. And heat from any fires that are burning. Maybe you have an open fire, or from a heater inside, or just the heat from people that live inside the house. That's another 33 units of heat. And then all the heat that leaves the house, so ventilation, that means any heat coming out through open windows gets lost. All of these types of heat here, transmissions, that means heat that's lost coming through the walls or coming through the roof, or any other heat that goes through the ground or as hot water. That's all lost as well. And according to the law of conservation of energy, the total amount of energy that went in should equal the total amount of energy that's going out. And if you add up all of these numbers of the heat going in, we get 630 units. And if we add up all the energy that's leaving the house, we also get 630. So this is a demonstration of conservation of energy.